Thank you for the opportunity to present today regarding the intelligent edge and specifically cybersecurity and how it affects it. It's really one of my passions to understand that, and it's something that's been kind of causing an issue with a lot of customers and a lot of vendors out there regarding how to handle the security threats regarding IoT and the devices themselves. So today's presentation is basically going to go over talking about the intelligent edge and also getting into some of the threats that we're facing, as well as some of the countermeasures that are in place today. And as everybody well knows, this is a very fluid environment, and we're going to things, by the time I get done the presentation, I'm sure things will change, but we'll kind of lay the framework of what cybersecurity, where it stands right now in regards to IoT and specifically the intelligent edge itself. So without further ado, I'm going to go to the next slide and talk about or get into Dr. Bradicic from HPE. Basically provided a framework which he calls the 3 C's of the intelligent edge, and we'll talk specifically later on regarding the location of the equipment, if you will, its place, the value that it provides. But really, there's he alluded to there's 3 main factors in defining an intelligent edge. One is connectivity, and that's basically providing a pervasive connectivity or network, if you will, from the edge or the IoT devices themselves through the network and then possibly to either the data center or the cloud itself. Also, the computation capabilities in the device provides the ability to possibly do, like in a video as a sensor environment, if you have that running, to do some inferencing right there within the device itself, so that it doesn't have to go back to either the data center or the cloud to do the calculations and provide the information back to the endpoint or the user themselves. So it basically speeds up the process and provides and reduces the latency of that computation. And so the other thing would be control, the ability to control the environment or the endpoints or the applications, if you will, at a quicker speed, and so improves efficiency. So it gives you that ability to move quicker and provide the ability to make changes as you go. And some of this, by the way, can be taken care of automatically with things such as AI or ML, machine language and artificial intelligence. And so you have those capabilities. So basically speeds up that process and gives you the ability to have things move quicker when they need to, and gives you that advantage. So the next thing that we would get into is what is the rationale for having compute at the edge? Well, it's many different factors. And in the world that I live in right now is dealing with IT and OT. We're working quite, at refineries, manufacturing facilities. And so you have, there's a need to not only speed up the process, but also the cost and reliability, and also, of course, following compliance. But in these are the markings, if you will, of what the rationale for having compute at the edge, and basically have an intelligent edge. And that would be, latency, reducing the latency. I referred to earlier, if you have something like a use case where you have video as a sensor, you want to do the inferencing right there as close to the edge as possible, so that it would reduce the time to respond back to either a device or the user themselves. And of course, that would also reduce the bandwidth, because you don't have the information or the data, if you will, traveling from end to end to do the calculation multiple times. And if you think about it, it's quite a bit. If you get into some like AI calculations or ML, you want all that to be at the edge as much as possible. Of course, there's the cost factor, and by not having that the need, if you will, for the bandwidth requirement, it thus reduces your cost on the services and as well as the networking equipment that you have in place. And the other thing too is threats. In regards to threats, it's really important these days to be cognizant of the fact of the data that is traveling from end to end, and by being able to minimize that traffic or that information, if you will, then it would reduce the entry point or the area of attack for an adversary to gain information or personal information, if you will. And of course, there's, we have regulations. There's regulations within the United States as well as Europe that guard against the exposure of information and data. In the United States, it's things like HIPPA and GDPR in the United Kingdom or Europe. So you got to be cognizant of the fact of that. Also, duplication. There's not a need when you send that information across from endpoint to endpoint. The need to or the fact that information might be duplicated and basically sucking up a lot of the resources that aren't needed if you were to have the compute device or the intelligent edge device, if you will, to provide that capability at the endpoint. Instead of having the information going across and having to be stored in memory or storage, you have basically reduces the fact of the resources that are going to be utilized. And reliability with this connectivity from the endpoints, it provides the ability to encrypt the information and make sure that the information isn't accessed, if you will. And so that gives the ability to removes the entry point, if you will, for an adversary to get into the information. And we've already talked about the compliance issue, so I won't belabor the fact on that one. So let's talk about the importance of the security edge itself, and more importantly, where are things located? Intel had provided this a really interesting diagram. I thought it would lay it out pretty well for us. And basically, it's really where are the entry points for attacks. And so you can see you've got the devices on the edge, and the devices could be anything from an IoT device, could be a video, or it could be some kind of pump, if you will, if you're into an OT environment. Also transportation, it could be an autonomous vehicle. So it could be anything like that, retail, it could be smart cities. It's really any type of data source, if you will. And so you've got on the left, you're gathering the information, or you're gathering the data itself, and then you're transmitting it to the edge node, which is what's labeled here as a compute node. And that compute node right there is really where the intelligence kicks in, and what we were talking about, the intelligence edge itself. From there, you can do computations, and if you need to go to the data center or the cloud, if you will, you can certainly do that. But if the task can be taken care of right there on the edge, then once again it would increase the efficiencies and be more productive, if you will. And then you go across, the traditional infrastructure with the network hubs or regional data centers, and that's your server storage networking capabilities from basically the hub through the core network and out to the cloud data center itself. But the main point is that if you look at this diagram, when you get into cybersecurity, and if you take a myopic approach and look at, hey, I just need to care about one particular area, well, I think that's futile, because the fact that cybersecurity encompasses the entire end-to-end of your transactions, of your infrastructure. And so you have to be aware that not only the IoT devices themselves, but also the networking equipment, as well as the data center itself. They all have to work hand in hand to alleviate or try to mitigate risk. And that's really what it's all about. You can't just look at one entity, if you will. And then I wanted to take a look at the what are the target attacks, if you will, specifically the is it the categorization, if you will, of the attacks, and the chart above, the one in the middle where it says 1900 plus, that one basically is FireEye's attempt to categorize the different attack vectors, if you will, and basically it's broken down in the three quadrants, and that is one for financial, and then two for the APTs, the persistent attacks, and then three is uncategorized. And so you can see the different, adversaries, if you will, like financial, it would be, Russia and others. And then in the far right for APT, it would be simply, the other countries such as Korea, if you will. And then on the left side is the uncategorized entities. And it's just a way to look for overlapping attacks or mechanisms in which the adversaries are actually using this information, and what tools are they using? Are they using the same information? Are they using the same tools? So this is a way to kind of break down and basically find the root cause or the root of where these attacks are coming from, and as well as what methodologies are they using. And one of the interesting things was that as they go through the process of trying to understand a lot more about these adversaries, is that they discover that organizations, the actual number of threat groups, actual different types of attacks within organization is more than one, because once they are able to exploit an area and get into either the government or private sector, of course, it just grows quite a bit. And it goes, and basically from 2019 or 2020, it went from 15 incidents to 29 within each customer. So that was the medium of what they were able to discover and unravel. Now, the other thing too is dealing with the dwell time. And this is actually a good thing to see, is where in 2019, the dwell time was at 60, and in 2020, it went all the way down to 17. Basically, the dwell time, for those that you might not know, is really from the time that the attack happens to the time that it's discovered. And so, and that's always been a problem in the past, is that these adversaries were able to get into the network and into your environment and figure out and lay low for a while and gather more information without the organizations knowing about it. And so here, what's happening is the systems are getting smarter, as well as I believe that the organizations are getting smarter with their resources, and they're able to detect that they've been infiltrated a lot quicker than they have in the past. So that's a good news, because time is of essence, and being able to figure it out as quickly as possible, of course, is key. The other thing too is, what I found interesting is what industries are being targeted. And this chart from FireEye as well is dealing with, the things that are kind of interesting to me, is the fact that a lot of the retail and hospitality have stayed in the top 5 for a few years, if you will. And the one that's really surprising, is kind of jumping to the top, would be medical or healthcare. Of course, you would think financial would be there, but the healthcare industry is being targeted a lot more than what it was in the past, and it's rapidly rising through that. And so there's another term out there with the IoT, so medical technology, and so you've got be aware of that as well. And of course, that brings aboard a lot of different other issues regarding the healthcare system. But right now, I would say the biggest targets out there, besides the business and professional services, would be, of course, financial and the medical or healthcare industry itself. The one that dramatically dropped down quite a bit, which is somewhat surprising, is the media in the media industry itself. And we all remember, not too long ago, the Sony attacks and other industries or other media outlets that were targeted for information, if you will, or to compromise their stability of the organization itself. So with that idea, so we got the idea of the types of attacks or industries that are being targeted. But I came up with this list here actually through IT Chronicles. And of course, these top security threats are, they're fluid and it changes, day in and day out. But there's a lot of them that are kind of the, standard ones that you would expect to see. The distributed denial of service, of course, is one that we all love and dear, if you will. And it's the standard things like the ping of death and basically to target service outages, and if you will. But and also the standard man in the middle attacks. Everybody's aware of that, and the malware and the spyware itself. And the big one that's stepping up right now is the ransomware. Of course, that one's taking a lead of the actual security threats that are out there. And that's getting a lot of news these days, as we well know. And so what I've done is I've highlighted really kind of the ones that are in red are really kind of the predominant ones that are hitting us right now. And I would have expected the password attacks or social engineering, which includes phishing, because those are really the ones that have stood out for quite a bit. So that's not too surprising. Ransomware, well, that's the new kid on the block, and of course that one's getting all the attention, if you will. And another thing too, I always find sometimes you find these cybersecurity stories or encryption stories that you hear about. And I came across one where there's a gentleman by the name of Thomas Begay, who's actually a code talker. And I'm sure most of you have seen or heard about the movie with, about the Wind Talkers. And so this gentleman happens to be a Navajo Indian, and he actually served in three battles, if you will: World War II, Korea War, and the Battle of Iwo Jima. But what's interesting about this is first of all, when they were using the Navajo language as a way, as a cipher, if you will, to keep the enemy from understanding what they were communicating. It was never discovered. They couldn't understand the Navajo language, so they were not able to break the code, which I found really interesting. But what they also did was they double encrypted it. So what they simply did was, instead of using their language and saying a plane is a plane and a Jeep is a Jeep and a car is a car, they actually use codes for different things. So you have to not only understand the Navajo language, but you would also have to understand what they're talking about. Specifically, as an example, they would use the plane would be labeled as a bird, and then they would go, they would name a car something else, and different things, or troop move. They would use different labels for different things. So it would make it even harder for them to figure out. So anyway, at the end here, what was really cool about this is the fact that nobody was able to, the Germans or the Japanese were not able to figure out or the Koreans, the fact that they were using the Korean language, and I always found that rather interesting. So anyway, Nicolas Cage movie, I recommend it. And the next thing is dealing with the actual implementation challenges, and this is what we've come across ourselves quite a bit. Like I said before, we're in the IoT or IT/OT environment. We do quite a bit of work there, and we see these top challenges, if you will, ourselves. And it really kind of, I would expect this is really what the top 10 list of things that you should, be concerned about to begin with. But really, a lot of sometimes the configuration mistakes that engineers make or within the facility causes issues. But a lot of times you get into like the web interface is insecure and you get SQL injections. And as well as dealing with the authentication authorization not being sufficient enough. And we work in we have some use cases where we deal with connected worker, and we have to go through that process of making sure that we're using the proper, since it's a connected worker and they're mobile, we use Wi-Fi, or you could use cellular. But you need to make sure that you use the proper or you follow best practices, and you use the proper frequency for Wi-Fi, as well as making sure that you authenticate and properly, either using bio or other means to authenticate to get from the endpoint to the data center or the cloud network itself. So a lot of these are standard. The lack of transport encryption, that's pretty darn important, especially with dealing with the privacy concerns. And the other one, what I would say is sometimes we forget about the actual physical security. If you don't have the boxes, or the equipment tamper-proof, and that could include, not only a lock or a box or something to prevent physical connectivity into it, but also the ports themselves, the management ports. You need to make sure that they're not available, so people or services, so that somebody who would want to exploit a vulnerability, that they couldn't do it with either a service that you weren't aware that was active, or a port that you didn't realize that was also active as well. So you need to disable those entities, if you will, just to make sure that there's no issues regarding that. Just one of those best practices that you need to follow. And then as I get into the talking about some of the threats and some of the countermeasures themselves, and this is a nice little Rambus put together a diagram that I found would really get our point across, and that is dealing with, and then this is not an environment similar to an IT/OT environment, which it is, dealing with a SCADA network and also dealing with a trusted and a least trusted network, as well as the most trusted network, and how do you combat where the entities, if you will, could get into the network. Like, for example, if you're, a device were hijacked, what's the countermeasure for that? And really, and that brings on another point. And then dealing with the environment, you need to make sure, that not only access control and lifecycle management, but it's the accountability or the knowing what assets that you have, an audit, if you will, of the assets, because a lot of times you get this growth of equipment, this sprawl, if you will, of equipment that happens to show up and you have no idea that it's there. So not having a good not having good visibility of your network, of the devices on your network, is a big problem. And that's where you can a lot of problems come up. And so there's tools out there that you can utilize to search and the network itself, and to have an accountability or a ledger of all the equipment all the devices that are there, who do they belong to, what are their IP addresses, MAC addresses, things like that. So you want a good list of what equipment is actually on the network, so you can see which devices belong to who, and where they should be, and then are they acting properly, the way that they should. And so there's a lot of threats here that are shown, like man in the middle or persistent denial service. And the countermeasures are what you would usually think of, like authentication, encryption, access control, DDoS protection, monitoring and analysis. And that's another thing too, is it's one thing to monitor a network, but if you don't maintain log files that are encrypted, they can also be compromised. And so you want to make sure that you have a way to not only gather intelligence, but also make sure that intelligence hasn't been tampered with. And so you can go back and do a forensic study of what happened and look for a root cause of what the issue might be. So anyway, that's just some idea to give you an idea of the different countermeasures that are pertinent to this particular environment here. And then some of the top trends, actually the slide didn't work the way well. I'm going to skip to the next slide and come back here. But anyway, when I was back in, when you first start out, and you start doing slides, they say keep the writing to a minimum. Well, apparently I didn't get that. I didn't learn that skill very well. But anyway, so these are just some of the countermeasures that are in place. So the good news is there's tools in place that we can utilize to take advantage or to counter the threats that are out there. And really, the one that I put on here right off the top of the bat was the employee cybersecurity awareness. A lot of people overlook this, and this is really, really, really important. And the fact that utilizing the workforce to be aware of possible issues and bringing it to your attention is really important, as far as providing an army of individuals that can be basically the first layer of protection for the network and the services that are out there. And so that's very important. And you can also do for example, password protection or making sure your passwords are strong, or phishing attacks. You can actually run through simulations and actually run that through the organization to test the individuals and to make sure that everybody's keeping up to snuff, if you will, regarding understanding what phishing attacks might look. Something might show up in their email, and that's really just a way for somebody to get in there and get their hooks and grab your credentials and get into the network itself. So there's quite a few on here. We talked about the tamper-proof physical network, but the other thing too is you got to start from the base platform, which is TPM, which is a trusted platform module. It's really the root of trust in the integrated circuit. So you have that. You want to make sure that the boot code, the boot OS, the firmware, your credentials for the keys are all protected. And so there's a term called TPM, which basically certifies that that is in fact in place. And the other one too, and I won't go through all these, but the other one would be the zero trust architecture or zero trust endpoint. And that is really dealing with verify first. Don't trust anything until you verify or authenticate. Don't let anybody or anything into your network until you go through the process and follow that methodology to make sure that, yes, that data or that person or that communication is valid. And so that's another important thing. And I'm getting kind of near the end here, so I'm going to make this real quick. And the last thing I can think about or wanted to talk about was the actual governance. And there's quite a bit happening out there. Of course, was the presidential directive to improve cyber communications or cybersecurity itself. And the other one was the IoT law that's recently passed that provides a framework or standards to help get our house of IoT in better shape. The unfortunate thing, it's fortunate but unfortunate. It applies to the federal government, but as we all know, things start out usually in the federal government with standards and regulations, and then it moves its way into the private sector. And let's see, the one more thing is what to show this slide here regarding, this is actually a use case that I've worked on. We're a refinery down in the Houston area where, we go through, the use cases or business goals where safety was number one, reduce the cost, optimize the operations. And of course, with OT, there's a lot of personnel that are senior, and they want to bring in younger, newer talent. But if you don't have the tools in place, sometimes it's hard to recruit individuals such as that. And so that what we did is we had the different types of solutions that we worked on for IoT were asset integrity management, connected worker, condition monitoring, predictive maintenance, worker safety, and of course, video as a sensor. So those are the things that are in play. It's operational down in the Texas area. And anyway, if anybody wants to see a tour, just let us know. And then the last thing before I turn it back over to Kevin is if anybody has any further questions or you want to continue this conversation, I would recommend reaching out to the IoT COE group that's dealing with the actual cybersecurity for IoT, and learning more about how we can protect the IoT environment so that you can sleep good at night. And with that said, that's all I've got for today.